students, Mr. Murphy here. We are going to go into lesson 2, linear and nonlinear expressions in X. So remember, linear, straight line. Nonlinear, not a straight line. Very tough to confuse those there. All right, lesson 2, standards. We're going to know the properties of linear and nonlinear expressions, and students will transcribe and identify expressions as linear or nonlinear. In our vocabulary one, students will be able to explain the difference between linear and nonlinear. Sounds pretty easy. Everything's linear and nonlinear. We're going to know what they are, tell us the properties, transcribe and identify. I can do this. All right, we have definitions for linear and nonlinear, and we know how to use the definitions to identify things as linear and nonlinear, and we can write expressions that are linear and nonlinear. Sounds pretty easy. Let's take a look. So let's take a look at our definition. A linear expression is an expression that is equivalent to the sum or difference of one or more expressions, where each expression is either a number, a variable, or a product of a number or variable. Okay, it's not so difficult. Remember our terms from the vocabulary video. A term is a number or a letter or a coefficient and a variable like 3x. As long as you're multiplying those numbers, they're one term. But as soon as you start adding or subtracting these things, then they become separate terms. An expression, a linear expression, is just a group of these terms. So down here we have some examples. 4 plus 3x, 7x plus x minus 15, 1/2 times x times plus 7 minus 2. Those are all expressions because they have more than one term. If you have just one term, it's also an expression. Now, a linear expression is any expression where the x has a power of 0 or 1. Well, we know if you have a power of 0, it's 1. So if we just have a 1 in there, that's like whatever. So really, you'll only see powers of 1, but you won't even see that because if you remember from exponents, anything to the power of 1 is the same number. So x to the power of 1 is just x. So why am I, as a lazy mathematician, going to write x to the power of 1 when I can just say x? So all of your linear equations, you will have, if they have a variable, the variable will just be that. No powers, no exponents. Nonlinear expressions are anything else. So here we have 2x squared. So the x is squared. It's a nonlinear expression. Negative 6x to the power of negative 3. Nonlinear because it's a power of 3. 1 divided by x. This is tricky. If you're dividing by the variable, nonlinear. Just weird that way. Okay. We'll talk about that sometime, hopefully soon. If you just have numbers like 3 to the power of 3, that's still linear because 3 to the power of 3 is 3 times 3 times 3, which is 27, which has no power. So numbers raised to a power don't mean anything. It's the variables raised to a power that mean something. Okay, so let's sort these into groups. Negative 0.31x plus 7 minus 4.2x. That's linear. Here we have an x to the power of 1. That's linear. This one is linear. So all of those are linear. X squared, nonlinear. X squared, nonlinear. X to the negative 4, nonlinear. X to the x divided by 2 to the power of 3, nonlinear. Here are a bunch of x's, linear. And this last one, linear. So we can separate these into linear and nonlinear. Remember, linear means straight line. Nonlinear is curved. So if you graph any of these nonlinear equations, you're going to get some sort of curve. But all of the linear equations will graph a straight line. Okay. Linear expression where each term is either a constant or a product of a constant and x. So it's either a number or it's a variable or a number times a variable. So 57 minus x is linear. because it's 57 minus x. 2x squared plus 9x plus 5 is nonlinear. So this one here is 57 minus x, straight line, crosses by 57. This one here is 2x squared plus 9x plus 5. It makes a curve. Linear and nonlinear. Right. So you're going to tell me, linear and nonlinear. How many terms? How many coefficients? How many variables? What's the power of the variable? Is it linear or nonlinear, right? So how many terms? We got two terms, 4 and 3x plus 3x to the fifth. How many coefficients? 3 is the coefficient, so we have 1. How many variables? We have one, just an x, so we have one variable. What's the power of that variable? 5. Is it linear or nonlinear? That would be nonlinear because the power is 5. This one, we have 7x plus 9 plus 6 plus 3x. How many terms? 1, 2, 3. I have 4 terms. I can combine them and end up with 2 terms. But right now, I only have 4 terms. So it's 4 terms. I have coefficients. I have a 7 and a 3. So I have 2 coefficients. How many variables? I have an x and an x. So I only have 1 variable because they're both the same. And what is the power of the variable? So both of them have a power of 1. So is it linear or nonlinear? That would be linear. So you do these ones. These are going to be your questions. Some of these are going to be your questions on the go formative. So the square of the sum of 6 and a number, would that be linear or nonlinear? Remember, square means to the power of 2. So that would be nonlinear. Okay. All right. So we have definitions for linear and nonlinear. We know how to use the definitions to express linear and nonlinear. We can write the expressions as linear and nonlinear. So the definition for linear and nonlinear is if the terms are all to power of 0 or 1, then it's linear. Anything else is nonlinear. So I can identify which ones are linear and nonlinear, or I can write my own. Okay. Expression that is equivalent to the sum or difference of one or more expressions where each expression is either a number or a variable or a product of a number and a variable. So a number like 3, a variable like x, or a product of like 3 times x. As long as x, the variable, has a power of 0 or 1. Okay. All right, that's it. We know the properties of linear and nonlinear. We can transcribe or identify expressions as linear and nonlinear. And if you write down your explanation between linear and nonlinear, I will give you homework credit for that. Questions, comments, complaints? Send them to my email so I can ignore them. Bye.